All right, let's find the derivative of the sine of x. All right, so the derivative of the sine of x, or f prime of x, is equal to the limit as delta x approaches 0 of the f of x plus delta x, which is the sine of x plus delta x, minus the f of x, which would be minus the sine of x, all divided by delta x. It's the limit definition of the derivative, right? It's the limit as delta x approaches 0 of the difference quotient. So we're calculating this derivative by definition. That's the definition, the limit definition of a derivative. Okay, well, if I initially plug in 0 for delta x, this turns out to just be 0 over 0. So there's some common factor that I'm going to be able to cancel out to calculate this limit. So let's go ahead. Let me see. I see here that I have the sign of a sum. And I remember the sum and difference formula from trig said that if I wanted, let me write it here. I believe that sum and difference formula says that for the sine, if you have the sine of u plus or minus v is equal to the sine of u times the cosine of v plus or minus the sine of v times the cosine of u. So in our case, what we have is this. This is equal to the limit as delta x approaches 0. And I'm going to apply that sum and difference formula to this term right here. And I will get the sine of x times the cosine of delta x plus the sine of delta x times the cosine of x, and this is minus the sine of x, all divided by delta x. All right, great. So we have this expression now. And what I'm going to do is I'm going to factor out the common factor sine x out of this term and this term. And I'm actually going to factor out a negative sine x. So I get f prime of x is equal to the limit as delta x approaches 0. And I'm going to factor out a negative sine x. If I factor that out, let's see. If I factor it out of this term here, I'm going to be left with a positive 1. If I factor it out of this term here, I'm going to be left with negative cosine of delta x. And it doesn't occur in this term, so I'm just going to leave that term alone as the sine of delta x cosine of x. And this is all still divided by delta x. So what I've done, I see that there's a common factor sine x here and here. So I factored out a negative sine of x. It leaves this only factor being 1 for this term, and it leaves the only factor of this term, negative cosine delta x. All right, now I'm going to split up this numerator. I'm going to split it amongst two denominators here, limit as delta x approaches 0. So I'm going to keep this negative sine x 1 minus cosine delta x all over delta x. And then I'm going to have plus, and this is going to be uh, cosine x times the sine of delta x, all divided by delta x. All right, so I've split it up. This term, I divide by delta x to get this. This term, I divide by delta x to get this. All right, so in terms of delta x, the factor sine x is a constant. So f prime of x can be written this way. Negative sine x times the limit as delta x approaches 0 of 1 minus the cosine of delta x over delta x. and then plus. Also, in terms of delta x, cosine of x is also a constant. So that can come out. Cosine of x times the limit as delta x approaches 0 of the sine of delta x over delta x. And these are two limits that I actually know. Well, this one, the limit as delta x approaches 0 of 1 minus the cosine of delta x over delta x, that limit goes to 0. So this is 0 times negative sine x, which is 0. And this other one here, well, the limit as delta x approaches 0 of the sine of delta x over delta x, that limit is 1. So that's 1 times cosine of x, or just cosine of x. So it turns out that the derivative of the sine of x is just the cosine of x. So you see, if you start off with the function sine x as your f, as your function, and you want to find the derivative of the sine x, the derivative of sine x is cosine x.